Okay, hello, Garnet here. And I'd like to talk about brain entrainment and brain engagement. On the title of the video, it's expressed as brain entrainment versus brain engagement. But I don't mean versus, I don't mean like a competition, I guess it's more like comparing. So, we'll see how long it goes. If it's a little bit longer, I'll do it in two parts. Okay, first of all, brain entrainment has a kind of a reputation. It's reasonably well known by certain people, and the concept is relatively simple, but the subject itself is not so simple. So let's first of all talk about brain entrainment, and then that'll let us talk about brain engagement as a comparison. Okay, don't really have this planned out very well, so where shall we start? The concept of entrainment, brain entrainment, also called neural entrainment, also called frequency following response, which is a little bit more of a term used with sound. It's a concept that came forward in popularity in the early 1970s. A fellow named Osler, great researcher, published an article in Scientific American about audio or sound related brain entrainment. And in and around the same time, a very prolific researcher, controversial researcher, Robert Monroe, was also bringing a lot of the information forward, not so much from the neurological scientific, but more from the conscious, maybe mystical side. So brain entrainment. The idea is that the brain is electrical, it's chemical electrical, but the signaling within the neuron itself is electrical. And it became apparent, I'm trying to remember the dates, like in the mid-late 1920s, and I can't remember the person's name. Oh well. And he began to notice that there were very distinct brain wave frequencies being emitted from the head. Actually, that was recognized about 50 years earlier, but he was the first one, I guess with enough of the technology, to begin to capture it, to appreciate it. He's Hans Berger, I believe. Hans Berger, I think is his name. He's the one that we can thank, or maybe not thank. He's the one that named the delta, alpha, beta brainwave ranges using the Greek alphabet, and there was no real logic to it. He just designated them that way, so it's not as though one is more important than the other. They don't even go in sequence, as you'll notice. So the idea of brain entrainment, you know, one of the most fascinating ways of kind of investigating something is to access, in our case mostly read, information that was published either in academic research or in popular books or in other media about what is happening and what it's going to do. And then you read those sources many years later, and you get to have a kind of a sobering assessment as to the accuracy, the validity of some of the concepts. Brain entrainment is one of those. And if you really want to go into some depth, and it's good reading, it's dated, but there's a book published by a fellow named Hutchinson, mid-late 80s, around 1986, about 30 years ago. It's called Mega Brain. And it's a compilation of all the stuff that had been happening for the previous roughly 10, almost 15 years, because all of this popped open in the early 1970s. I'm fortunate enough to be of an age that's when I was in university, and that was a lot of what I became fascinated with just as it was emerging. So for me, it's not just a kind of a social history, it's personal history. You may have even come across, heard, there was a term that came forward that held a lot of the projected promise about brain entrainment at around that same time that biofeedback was exploding. It was pretty exciting stuff because it was all happening at the same time as the human potential movement, the same time as the psychedelic hallucinogen concept, and a lot of social change as well, especially in the US, but across the world. So even there was a term called superlearning. That was the promise that brain entrainment was one of the vehicles, one of the techniques, the modalities that was going to create a whole new host of potential actualizations for the human potential movement, and superlearning. Well, when you read the book Mega Brain, which was a kind of a must-read book by the mid-late 80s, I think it was published in 86 or maybe even late 88, but all of the references are from the mid-early 80s and of course throughout the 1970s. And you see all of these things and what appear to be so ripe, and then you have to ask, especially for those of you, say, born in the 80s, what happened? Why did it plateau? Why did it flatten out? Why are we not in the midst of a whole new medical, psychological, spiritual, social revolution that this was in many ways promising? Why can't you learn 5 languages quickly when you're over 40 years old, and creativity and so on? So I've said this before, and this is in no way a criticism and especially not a condemnation of brain entrainment, because it's a very useful and important appreciation. The question is asked, does does brain entrainment work? And I have to say, in my opinion, getting over a cold, sorry. In my opinion, the answer is yes, it does work. And then there is an important follow-up question, well, does it work as well as we had hoped? And the answer, unfortunately, is no, it didn't. And so, brain entrainment. Brain entrainment is the understanding that you can kind of coax the brain's electrical activity expressed through different specific brainwave frequencies. You can coax it into a certain kind of rhythm. You can do it in like 3 different ways, and some of them overlap. Most famously, and it was used in the beginning, was sound, audio. Then there's visual, and then there's tactile, touching. And a 4th one, which is very little investigated, is electromagnetic. So, of course, you could say, well, light is electromagnetic, but I mean, not in the visual range. So, the thing is this, and I'm going to try to not go on too much about it, and I'm doing my best to avoid technicalities, but the brain does not have one frequency at one time. That's the first thing. It's a multitude, and the frequencies share the stage, share the brain. And a lot of what we get when we do EEGs, of course, is cortical. It's more superficial. The cortical area, the cortex, is the newest part of the brain. It's extraordinarily important, so I'm not minimizing that. It's just that it's not the whole brain. And then you talk about the 2 hemispheres, and maybe you've heard things about like hemisync. It's not sync, like synchronization, hemisync. That's out of a lot of Monroe's work, with the idea of getting both hemispheres to be in the same frequency. And you see, it's not even that it's a particular frequency, it's also the amplitude of the frequency, you know, how strong the pulse is, I guess you could say. So it isn't just whether it's 5 hertz, but is it 5 hertz with very large mountain peaks? Is the amplitude great? So there's a lot that's going on with that. And the hope was that it would be a form of training or learning. And if you say yes, it is, you have to admit, and the research supports this, is that it's a weak form of training at best. The brain likes novelty, it likes complexity. I don't like the concept of balance, I like the concept of harmony. That as long as it's a harmonious relationship, at times when one is high and one is low, it doesn't mean that it has to be, you know, equivalent as a balance. So, rambling a little bit, I guess, here. The point is that in the truth of the extended research in brain entrainment, I'll talk a little bit about binaural, because that's like, you know, the big deal, it seems. The fact is that you get paradoxical experiences. See, there are people that are easily hyper excited. It's hyper arousal. That's a kind of a state that they exist in. And I suppose as a consciousness state, you could say it's high creativity, but it's also high anxiety. There's that. And then there are those that are more depressive. Not so much excitatory, maybe more inhibitory. They're more depressed, and you could say maybe they appear to be more calm, more, I don't know, something like that. But see, the thing is that, and this is well known now, that you can get paradoxical effects if you stay narrowly focused on a certain frequency or a very small set of frequencies and try to keep the brain there, you know, focus it, keep it there for 20 minutes, 30 minutes, an hour, because you want the associated subjective state. The problem is that you will get, with some people, the opposite effect. The anxious person will become more anxious. The depressed person will become more depressed. And that's the truth of it. You know, there are new interests in these things these days because of all of the new findings in neuroscience and specifically brain science since 30 years ago. Because everything pretty much topped off by the mid-late 80s as far as this whole field. In terms of biofeedback, which is kind of a sister area, really the only one that really held its own is neurofeedback, which is a different principle. It's not based on the brain entrainment. I won't go into that discussion. It's viable, it's laborious, it's in some sense even tedious, but it is reasonable and functional in theory. So, brain entrainment is the idea of getting the brain as much as possible in a unified state and holding it there. And in my opinion, that is not really native to the brain. It's a special state. I think it's probably closer to trance than it is to increased consciousness. Because trance states will narrowly focus on a certain band and hold there. I mean, the whole thing of trance in general, through cross-cultural, but also trance music and, you know, rave and dance music, where it will hold and hold and hold and hold and hold, and you will be in a sustained alternate state during that period of time, and it's holding you there. It's not a learning process. Yeah, I'm sort of going a little bit like that. You know, there's like a fascinating study, it's only 3 years old, combination US and Netherlands, and published in, I think, Frontiers which is a very respected journal. And they're exploring binaural beats in relation to enhanced creativity. Okay, I'm trying to remember the project. And what they did is they used binaural, and I'll talk a little bit about that because that's a kind of an interesting one. But they used the binaural system. The binaural is when you have two different tones, and let's say it's 240 in this year and it's 220 in this year. So the difference of 240 and 220 is 20. So what you actually hear with kind of like a volume is you hear 20 hertz. So that's how you create binaurals. You can only do it with the ears, the sound. And they chose alpha at 10 hertz and they chose gamma at 40 hertz. And I'll just make a kind of a summary statement. They didn't get what they thought. One of the things is they saw, there's an interesting neurological reflex. It's called the eye blink rhythm, EBR, or rate, eye blink rate. And if I can recall, the slower the eye blinking, the lower levels of dopamine, and the higher blinking, the higher levels of dopamine. If I'm remembering correctly, it might be opposite, but I think it's that. And what they found was that the brain entrainment process had opposite effects on the subjects depending on their eye blink rate. So, and there's also the stuff called convergent and divergent thinking. Forget about that. The point is that it helped some kinds of thinking, but it made other kinds of thinking less. It degraded it. So what they saw is that it was quite unpredictable if you thought that people were the same, meaning that a 10 hertz will always do a certain thing and a 40 hertz will always do a certain thing if you isolate it, which is what they did. And the other thing that was quite fascinating is that they found that there was no difference between 10 hertz and 40 hertz, that they performed equally even though they're radically different in terms of their rate. So they thought it had to do more with a kind of a global effect, and the outcome was, well, geez, this is not as simple as we hoped it would be. So this is a very fresh and new example of neurological research with a lot of new tools being given access to us. So, okay, I think I'm going to stop now. This may end up being 3 parts. I think this is enough. It's a little bit, I would like it to be more cohesive, but frankly I didn't write the thing out, and I just want to talk a little bit in an honest way, to the best of my ability, about brain entrainment, and then also to introduce this concept of brain engagement, which is my best effort at giving a title to the way that the neurolight is designed to signal the brain and message the mind. So let's call this part 1 of brain entrainment versus brain engagement. Thanks.